Hello there people, this is Christian. Welcome back to my computer and Fusion 360 this Sunday morning. And this is from a Facebook question in the Facebook Fusion 360 user group on how to make like an oscillating cam like this. There will be a pin running on this. We will show first the basic workflow of getting the shape and what's the problem with the shape and how we fix it. Because if you just do the first steps on the workflow, you get a oscillating cam shape, but the pin or the roller that's going to run it will not run correctly on the shape. We'll have a look at that. So let's start this design. As we can hear, so the design intent is that it says a straight line from here to here, so we get, and this surface is always parallel to the ground, and it's also in this case when we start, the edge here is normal to the center axis. We're going to have a look at it when we create it. We're going to create a new design. Start by saving, create components, whatever you want to do. I'm going to create a sketch from the front. I'm going to do a line. I'm going to start with the center line of a design. I'm going to start with a line here that's going to be used for the cutting function in a while. And we're going to do the side edge here and a line from here to here. Now we start adding some constraints. We need a perpendicular down here, like that. This line here is just for construction. So let's go to construction. This here is our center line, so let's make it a center line. We're going to use midpoint from here to here. That locks down things nicely, like that. And let's start with our height. So this here is going to be the highest part of the cam. Let's do it like 80 millimeters. We're going to need a diameter, so we're going to dimension from the center. That's a good thing by doing the center line. When we do it now and select the dimension like this, we automatically get the diameter dimension. So let's see, it was supposed to do 60 millimeters. That's nice. And for some reason, Fusion always pops up the diameter. I don't know why. I want it down here. And of course, we need the displacement of this cam. So I'm going to do it like this. I want this here to be 20 millimeters. So we have a 20 millimeter movement of oscillation. And once again, you pop up in the way. So with that, that's all I need to sketch. So we're going to finish sketch. For clarity, we're going to open up a sketch browser and have a look. We have a fully defined sketch. Good. We're going to use surface and we're going to do a revolve. And it automatically pre-selects some things here, but we're going to undo the profile selection. Check the So we move the axis, we're going to do it like I want to do it. Select profile, turn off chaining, because we only need this line here. And the axis is of course our center line. It goes all the way around, and we say thank you, so hit OK. We have a new body. The thing we need now to do is trim off the top of it, so we're going to use the trim tool. Trim tool is going to be this lines here. Yes, it selects both, that's no problem. It's just going to trim off this top here anyway. Hit OK. So now we have, if I look from inside, we have the outer side of things here. So now we're going to add the thickness. S on the keyboard, start typing in the thickness, or thicken. For this, we're going to do it inwards. Let's say we want a 10 millimeter wide cam, so -10. Open up our browser. We have one body too many here. I don't want things left over in my design advance. So I'm going to do highlight it by clicking on it and then right click and select remove. So we only have one body. I'm going to hide the sketch. So now we have like a basic cam. If we look from the front here, we can see this is parallel. Let's do it like that because hidden faces. We can see here this is parallel to ground, this is parallel ground, and here it meets, and this happens to be exactly in the middle. So what we have here is like a shape that this face is always parallel to, and any point is parallel to the bottom plane here, and there's always perpendicular to the center point. So that's quite good, but there's a problem if we want a pin to run here. We can do this and do the mirror mate of this. I've done that for some gates that turns around. 3D printed this to get the gate into like locking into one position. It stays here when you turn it around, it goes lifts up and rides on this, and when you drop a gate it goes back and stops here. But let's have a look at this here. I'm going to turn on my pin here. I have made this little thing. We're going to look at the pin like this, and this is the bad geometry, yes. And now I'm going to check here. I have orthographic views. I can check how the faces are interacting. So this is if we had a pin running on this here. We move it up first. So you can move this up and down. I'm using joints so we can have a look at this. So if you think you move this downwards until it hits the cam surface, you can see that it first hits the inside edge. Because the problem with the workflow is that the tangent point of a flat point is exactly down here, but the pin is not running on this point here. It's running on a point that is where the center point is normal to this edge the whole time. So this will, if you do this with the pin, is gonna scratch this edge all the way around. It will scratch outside a bit down here and stuff like that. So this is not really a good shape. So we need to do something more of this. We have done everything like earlier. We now need a small parameter because we use it twice, so we'll just do it, add a parameter. We're going to add a pin or roller, I want to call it. Let's say it's going to be 8 millimeters. So we have it up as a parameter now. So what we're going to do, because we want to stay the same height, we're going to do an offset face here later. So we need to go back and edit our sketch, and in this here, we're going to add our pin parameter divided by 2, like that. Finish. So now this gets a half pin diameter higher. That's good. S on the keyboard, start typing in offset and use offset face. On this face here, we're going to do that minus our pin parameter divided by 2. Like that. And we should have, check our sketch. Are we in correct position? Yes, we are still hitting this here. Good. So this is a new shape. It's a bit hard to see here what's going on, but if we go back to my example here, and I now look from just to look at again, look at this face here, you can see the pin is hitting up here. If we now turn off this and turn off on the correct shape, it gets a bit lower down, but as you can see, the pin now hits where the face is now parallel to the normal of the center line here. It does the same thing all the way around. If it's wrong, please show me it's wrong. So if you're going to have a roller running on it, do the basic workflow first, and then do an offset of this face, the top face, downwards with half the size of a roller or a pin. And you should get the correct geometry on how this cam should look like. So that said, take care, see you around, and goodbye.